Hello everyone, in this video I'm going to show you how to troubleshoot battery issues in your motorcycle. So you may have a motorcycle that's stuck at home that won't start, or you may have a motorcycle that is cut out on the side of the road and you suspect that the cause of the problem is battery related. So the first thing that you're going to need to do is you're going to need to confirm that there is a problem with the battery. That is where you start. So I have removed the seats from this motorcycle so that I can get at the battery. The first thing I'm going to do is determine what voltage this battery is. Now this is a 12 volt battery. The batteries in some motorcycles, although quite rare, can be about 6 volts. So make sure you know the voltage of your battery. Now the next thing I'm going to need is I'm going to use a multimeter. So with the multimeter I'm going to set it to measure direct current voltage on the 0 to 20 volt scale. So it's this one here. So I'm going to set it to measure on the 20 volt scale. So that means that it can measure between 0 and 20 volts. So I'm going to take my multimeter. I'm going to set it up so that you can see it. You can see the reading. Okay. Now, make sure that your probes are connected into the multimeter correctly. The black probe should be connected into the COM terminal on the multimeter. As you can see, the measurement is 0 volts at the moment. I'm going to remove the little plastic cover from the little red plastic cover from the positive terminal of the battery. I know that this is the positive terminal because I can see that it says positive here. There's a positive symbol here, and I know that this is the negative terminal of the battery because it has a negative symbol. So the black probe is going to go to the negative terminal and the red probe is going to go to the positive terminal of the battery. So make sure we get a good connection. So we're getting a reading of about 12.18 volts. So the next thing that we need to know is that a fully charged 12 volt motorcycle battery will have a voltage of between 12.7 volts and 13.1 volts. And we also need to know that a fully discharged battery will have a voltage of approximately 11.4 volts. That's not an exact science, but it's a good indicator. Now, this motorcycle with a battery with a voltage of about 12.18 volts, it's a little bit inconclusive. So the first thing that you want to do is rule out some of the common battery related issues that are very simple to fix. The first of all is we want to check that we have good clean connections of the leads that are connected to the negative terminal of the battery and the lead that's connected to the positive terminal of the battery. So we want to check that they are nice and clean. If there's any dirt, oil or grime, it could cause a bad connection. The next thing we want to do is we want to check that the connections are nice and tight. It might look like the connections are bolted on securely, but that doesn't mean that they actually are. And through the vibration of the engine of the motorcycle, it can cause the little bolts that secure the battery connections to come loose over time. So I'm going to take a socket and a wrench and I'm just going to tighten them up. So it's just a 10mm socket usually. So I'm just checking that they only need to be hand tight, but make sure that they're tight enough. If your motorcycle was not starting, after you have tightened the connections, you can now go and try and restart the motorcycle. And I think you'll find in a lot of cases that the motorbike actually fires straight up. Or you might find that it doesn't cut out while you're out on the middle of the road. So the next simple issue that I'm going to check for is we're going to check that the battery is properly grounded. So the negative terminal of the battery should be connected to either the frame or the engine of the motorcycle to ground the battery. And again, there can be a bad connection at that grounding point, and that can cause problems for the rest of the electrical circuits in the motorcycle. So to check for grounding, we can again take our multimeter and we're going to set it to measure direct current voltage on the 0 to 20 volts scale. We're going to take our test probes and we're going to connect the red probe again to the positive terminal of the battery, and we're going to touch the black probe off a clean metal surface on the frame of the motorcycle, and we're going to take a look at the reading on the multimeter. Now, as you can see, it's giving a reading of 12.18 volts, which is the exact same as the reading I get between the terminals of the battery. That indicates that my battery is properly grounded. If I got a reading of 0 volts, or if I got a reading somewhere in between 0 and 12.18 volts, that would be an indication of a bad grounding, and at that point I would need to go and check the grounding point. And again, it might be just something as simple as dirt or a loose connection or a loose bolt. And the third simple test that we can do is we can check that the ignition was not left on. If the ignition is turned to the on position, even if the light was off, it is still going to use more power than if the ignition was off. So if you discover that your ignition was left on, the key was left in the motorcycle and the ignition was left on, then that is probably going to be the cause of your battery draining. So if you determine that none of those simple issues are the cause of your problems, and if you determine that the voltage of the battery is greater than 12.6 volts, then in all likelihood the issue is not with your battery, and it is probably not battery related. The issue is probably some other electrical component, and you will have to investigate further. If, on the other hand, you determine that the voltage of your battery is less than 12.6 volts, or maybe it's completely discharged and it's around 11.4 volts, then the next thing you need to do is you actually need to remove the battery from the motorcycle, and we need to set it to charge. We need to get this battery fully recharged before we do any more tests. To remove the battery, we need to disconnect the two connections. So we disconnect the negative lead from the negative terminal of the battery first of all. Just be careful that the bolt doesn't fall down into the body of the motorcycle, get lost. So we can now just remove that lead from the negative terminal of the battery. And what we're going to do is I'm just going to use an elastic band, and it's going to hold that lead away from the negative terminal of the battery. so it's not going to fall back onto the negative or onto the negative terminal of the battery and create a connection again. And we're now going to disconnect the positive terminal of the battery, and it is safe now to do so. And I can now remove that positive terminal and just move it out of the way. There may be a strap holding on the battery. I've already loosened it, so I'm going to move that out of the way. And there may be other electrical components that are possibly in the way. In this case, the fuse box, which sits here, has to be actually removed from its holder and moved out of the way. And now I can safely remove the battery from the motorcycle. So I'm going to take this battery now, and I'm going to set it to charge. So I take my black lead and I connect that to the negative terminal of the battery, and I'm going to take the positive lead and connect it to the positive terminal of the battery. Now it's giving a reading of about 12 volts. It's not 100% accurate. So I'm setting it to charge now, and as you can see, the voltage is increasing, and I'm just going to leave that to charge the battery. It may take a few hours to charge this particular battery. I think this one charges at a rate of about 2 amps per hour. When it's fully charged, it's going to indicate that it's full. Now, instead of waiting for this particular battery, I'm just going to move that out of the way. I actually have another motorcycle, a brand new motorcycle battery here. Which I have already fully charged, and I'm just going to measure the voltage of this particular battery before we put it into the motorcycle. So again, black probe, move that out so you can see it. I'm going to connect the black probe, and we're going to connect the red probe. So I'm going to connect the two probes, and we're going to get a reading. So it's about 12.85, nearly 12.9 volts. So that's what I would expect from a fully charged motorcycle battery. So take that away, turn that off. We can now connect this back into the motorcycle. Okay, so let's reinstall this battery. Okay. So again, when we're reinstalling the battery, we install the positive lead first of all to the positive terminal of the battery. Okay, sure it's nice and tight. I am not going to connect the lead to the negative terminal of the battery just yet, and the reason for that is because I want to do a test. So when the negative terminal of the battery is connected up to this lead, and when the positive terminal of the battery is connected up to its lead, even with the ignition off, there is a drain on the battery by the motorcycle. And the reason for that, it's called parasitic current, And the reason for it, or the cause of it, is because there is some electrical components in the motorcycle that are actually still draining a small amount of current from the battery, even when the key is not in the ignition and when the motorcycle is completely turned off. Those components are things like the clock in the dashboard of your motorcycle, and also some components such as the fan for the radiator are able to turn on and off even when the motorcycle is turned off and the ignition is turned off. So these components can drain current, and in some cases they can drain an excessive amount of current. So we want to measure this parasitic current drain. So to do that, we're going to take our multimeter again, and this time I'm going to set it to measure amps. So I'm going to measure direct current amps. Now to do that, on this particular multimeter, I need to take out the red lead, and I need to connect it in here to the 10 amp slot on the multimeter. And this slot is specifically for measuring amps. It is actually able to measure between 0 amps and 10 amps. Now if you exceed 10 amps, you're going to blow a fuse in the multimeter, or you're going to destroy the multimeter. So you need to make sure that the amperage that you're going to measure is not in excess of 10 amps. Now the drainage current, or the parasitic current, on most motorcycles should definitely not exceed 10 amps. So we set it to 10 amps initially. I'm going to set this up so that you can see it, get a reading. So I take my two probes and I'm going to measure. I'm going to connect the black probe to the negative terminal of the battery, and I'm going to connect the red probe to the positive terminal, or the positive lead, which connects usually to the negative terminal of the battery. And we're going to see the reading is actually coming up at 0. Now that does not mean that it's 0, it just means that there's probably a very low current being drained from this battery. So what I can do now is I can change the scale. Instead of measuring amps, I'm going to change it to measure milliamps. I'm going to set it to the 20 milliamp range. So in this range, it's going to be able to read any current between 0 and 20 milliamps. So it's going to be a more sensitive probe of the current. And I take the lead, I'm going to disconnect it from the 10 amp connection point, and I'm going to connect it back into the original connection point, which is for measuring milliamps, volts and ohms. So double check that your settings are all good as I've just described, because if you leave it in this particular slot here, then it's not going to measure it properly. Okay, so there's our multimeter again set up. So we're going to just touch it off and we should get a reading. So we're getting a reading of 4.75 approximately. We're going to make sure that we have good connections, so I'm just going to connect them up, making sure that they're well connected. So we're getting a reading of just under 4.79 milliamps. Or is that 5? I can't see. So it's something around 4.7, 4.8 milliamps. So is a reading of 4.7 or 4.8 milliamps good or bad for your battery? Well, here's how you find out. A quick calculation that we can do to give us a ballpark idea of how long our battery will last before it is completely drained or before we should recharge it is as follows. So the first thing we need to know is the capacity of the battery. So this battery here, it says 8 AH. So that means that it has a capacity of 8 amp hours. So 8 amp hours, so capacity is 8 amp hours. So if you were to drain this battery at a rate of 1 amp, it would take 8 hours to drain that battery fully. Now, each amp contains 1000 milliamps. Okay, so we actually have a capacity of 8000 milliamp hours. Now, we know that the parasitic current was about 4.75 milliamps, so we'll round that off to about parasitic current was about 5 milliamps. Okay. Now, what we can do is we can divide 8000 milliamp hours by 5 milliamps, and this will determine how many hours this battery will last before it is fully flat. So that means that it will last for about 1600 hours. Now, if we want to determine how many days that will last, we can divide that by 24 hours. 24 hours, we're dividing that. And that gives us about, approximately, not exactly, it's about 67 days. Now, we want to keep the battery charged greater than 80%. So we don't want to lose more than 20% of our charge. Okay, so that means that we can lose about 20% or 1/5 of the charge. So if it's going to last 67 days before it's fully flat, we can divide 67 days, divide that by 5, and that gives us an approximate figure, approximately equal to about 14 days before our battery has drained 20%. Now, that means that our battery, we need to recharge battery after 2 weeks. So if I leave my motorcycle sitting in the shed and it's draining a parasitic current of about 5 milliamps, it means that within about 2 weeks it will have lost 20% of its capacity, and at that stage I will need to recharge it, give it a full recharge, get it back up to 100%. So as you can see from those calculations, for a parasitic current drain of 4.7 milliamps is a little bit excessive, but it's not overly excessive. I can actually live with that. If I only have to charge my motorcycle once every 2 weeks when it's sitting in the shed, that's not such a big problem. The other alternative is that I start probing to find the cause of the current drain. So if the current was a little bit more excessive, I would definitely want to do that. So I'm going to show you how to do that, that probing. So what we're going to do is we're going to leave our multimeter set to read milliamps, okay? And I'm going to go to the fuse box. Now I'm going to open up the lid of the fuse box. You probably can't see it, but it has on the top of this fuse box, it has indications, or it has some writing which indicate what each of the fuses underneath the lid are for. So I have a 10 amp fuse for the turn signals, it just says signal. I have one for the head, which is probably the headlight. I have one for the IG, which is probably the ignition. I have one for the fan, which is the fan that's connected to the radiator. I have one for the meter, which is probably for the meters on the dashboard, so that would include things like the clock. And then we have one for FI, which I think is for the fuel injection. Now there's some amps, or there's some fuses here. One of them is a spare, and then the other is for, it says it's for the ABS. So that's the ABS on the brakes. So what I can do now is I can use the fuses to determine where the current is being drained from. Where is this parasitic current going to? What electrical component is actually using it? So for this measurement, I'm going to change the probes on my multimeter, just because I need my two hands to hold them. So I'm actually going to use some test probes that have alligator clips on the end of them. So I'm going to set it back to measure milliamps. It's going to be in the 20 milliamp range. So setting that up so that you can see it. So again, I'm going to connect my negative probe to the negative terminal of the battery, and I'm going to connect the positive probe, the red probe, to the lead that connects. So as you can see, I'm getting that reading, the parasitic current reading of 4.75 milliamps. Now what I can do is I can go to my fuse box and I can start pulling out fuses. So if there's no fuse, if I pull out a fuse, it's going to break that circuit and current can no longer flow. So what I can do is I can just determine, I can take a look at some of the obvious circuits that could be draining current, and I could pull the fuse from that and I should see the current drop either slightly or completely. So I'll start off with the fan circuit. So it's the third fuse furthest or nearest the camera. So I'm just going to pull that fuse. I just pull it out with a little pliers. It shouldn't be difficult. There's no change in the reading, so I can put that back in and I can confirm that the fan is not the cause of the current drain. So I do know that the clock or the computer in the motorcycle is going to be draining current, because otherwise how is the clock going to tell time if it's not connected up to the battery all the time? So I'm going to pull out that little fuse for the meter, this one. So there you can see the current has dropped to 0.01 milliamps. So it's basically gone to zero. So we can ascertain from that reading that the meter fuse circuit is the one that's draining all the parasitic current, and that would indicate that it's the electrical components on the dash. Again, if I'm not happy with that current drain, if I find that it's too excessive, it is slightly too excessive, I can start going to the dash and I can start taking components or electrical components such as bulbs, or disconnecting the clock to determine which component is actually draining the current. So if it was the clock that was draining too much current, I could disconnect the clock in the dashboard, and once I disconnect the clock, I should see that current decrease down to 0 or close to 0, and then I know that it's the clock that is actually the cause of the parasitic current drain. Now, the next thing we need to note is, let's say we pull all the fuses and the parasitic drain current stays as it is. It stays at 4.75 milliamps. Then we're in a situation where we are not able to find which circuit is actually draining the current. It appears like no circuit is actually draining the current. So, what do we do in this situation? Well, in this situation, we can note that there is actually some other circuits in a motorcycle connected up into the motorcycle battery, which actually can drain current, a parasitic current, and they're not actually connected up to any of the fuses. So one of those circuits, and it's usually the main culprit for a parasitic current drain outside of the fused circuits, that electrical component is the regulator rectifier. So the regulator rectifier is connected directly up to the battery, and it contains a number of diodes which prevent the current being drained away from the battery. If some of those electrical components, let's say the diodes or whatever it is, in the regulator rectifier fail or start to fail, then the current can actually drain out from the battery through the regulator rectifier, and it can be quite excessive, and it can grow over time. So how would you determine if that was the case? Well, what you can do is you can go to the regulator rectifier. It's on the right hand side at the front of this motorcycle. You'll probably see it in some of the other videos that I have. It's hidden underneath the fairings, but what I would do is I would just take off the fairing. I would have my multimeter connected up to read that parasitic current, and I would disconnect the regulator rectifier via the little connection. I would disconnect it from the wiring loom, and when you do that, it's a little bit like pulling the fuses on in the fuse box. You should see the current nosedive down to 0 or close to 0 or below that threshold, and that's how you would determine that a component such as the regulator rectifier is the cause of your parasitic drain, and is also the cause of your battery dying over a couple of days or a couple of hours. You may also have some aftermarket electrical components installed in your motorcycle, which are connected either directly up to the, usually they are connected directly up to the battery. Some of those components can be a phone charger or an aftermarket alarm system. They may be connected up possibly with a fuse or without a fuse, and again you can check them separately because they will probably have their own separate fuse, and you can pull the fuse and check if they are the cause of the current drain. So the next test that we can do on the motorcycle battery involves the charging system itself. So we want to check that the motorcycle battery is being recharged properly. So what we need to know is that the role, or the main role, of the motorcycle battery is to supply power to the starter motor to get the engine turning over. And once the motorbike is running, the alternator will supply power back to the battery to recharge that battery. So we can do a test to make sure that the alternator is supplying power or supplying charge back to the battery and recharging it. So to do that, we can connect our multimeter probes across the battery terminals, across the negative terminal and the positive terminal, and we can measure DC voltage again. Now, what we should expect is, if we have a voltage of about 12.9 volts across the battery terminals when the ignition is off, when we turn on the ignition, power is going to be drawn from the battery. So we would expect to see a voltage drop, a slight voltage drop, as the power is drawn from the battery. Now, when we hit the starter button to start a motorcycle, a huge current will be drawn from the battery, and we would expect an even further drop in the voltage. But we need to pay attention to how low that voltage drops on each occasion, when we turn on the ignition and when we press that starting button. And when we release the starting button and the motorcycle is running, we then expect that the voltage will begin to recover back up towards 12.9 volts. And if the alternator is working as it should be recharging the battery. And in that case, we would expect the voltage to exceed 12.9 volts. Now, while the alternator is charging the motorcycle, the power output from the alternator is dependent on how fast you are revving the engine. So the faster the engine is revved, the more power output from the alternator. But if you supply too much power from the alternator to the battery, you can actually overcharge the battery and damage it. So we want to rev the engine slightly. It's usually up to around 5,000 RPM where you can do that test. But at a certain stage, we should see the voltage across the battery terminals increase slightly as we rev the engine, but it should stop increasing at a particular voltage. Now that voltage is usually anywhere between 13.5 and maybe 16 volts. Usually it's around 14.5 as an average. So that's the behavior we should expect. Even if we don't know the exact numbers, that's the behavior we should expect from really any motorcycle that uses an alternator to recharge the motorcycle battery. So let's go ahead and do that test. So the lead is reconnected to the negative terminal of the battery. I've connected up my voltmeter, 12.83 volts. Turning on the ignition. Slight voltage drop, and now I'm going to start the motorcycle. Ignition off. So, after doing all of these tests that I've just described, and you determine that the charging system is working fine, you determine that there isn't an excessive parasitic current drain, all your connections are clean and secure, you're not leaving your ignition on, everything looks good, then you can kind of get to the point where you have to draw your attention to the battery itself. So it seems like everything is working perfectly. You now need to take the battery out and you need to bring it to your battery shop or your motorcycle dealer and you need to get that battery tested, because if everything else is working but you're still having problems with the battery starting the motorcycle, or if it's draining very quickly over just a couple of days, then that's a sign that the battery itself is bad. Batteries can go bad for various reasons, and you can also, batteries have a limited lifetime, so they don't last forever. I have seen reports that some of the lithium batteries have lasted 10 years and above, so there is some batteries that will last a long time, but most batteries have a service life of between 2 and 5 years. So your battery may just be getting to the end of its life, and it may be still functioning, but it just may not have the same capacity that it used to have. So when you bring it to your battery specialist, they can do some measurements on the battery. The two measures that they should do, first of all, is on the cold cranking amps. So the cold cranking amps is how much amps the battery can output when it's fully charged over a period of about 30 seconds. Now, this battery I think is rated for about 135 amps of CCA, which is the cold crank amps. So it means that it will output 135 amps for about 30 seconds. As this battery gets older, I may find that the output from that battery after maybe 2-4 years, depending how I service the battery and how I use the motorcycle, that cold crank amps may reduce over time to something of about 50 amps or even less. And at that stage, it's probably going to struggle to start the motorcycle. As well as that, the capacity of this battery will reduce over time. It's currently, when new, about 8.5 amp hours. That may come down quite considerably over the life of the battery. And then the other thing is, the battery specialist will be able to measure the internal resistance of the battery. Ideally, a battery, particularly one that's designed for starting automotive, like a motorcycle or a car, it should have as close to zero internal resistance, and that means that it can deliver a high current in it quickly for a sustained period. As the internal resistance goes up in the battery, the ability of the battery to deliver that power over a short period of time at high amps reduces. So that's it. Hopefully you found this video useful. Don't forget to like and subscribe to my channel, and I'll have more useful content coming soon. See you later, everyone.